Let's now go to the problem. That's to remember. Alright, so we have got this diagram. The first question says determine the gradient of CD. Now 4.1, you take a break for the lesson. Take a break for the lesson and put your grade down. Now the first question, 4.1, you need to find the gradient of CD. Now that's a grade 9 question. When you first taught gradient. So the gradient of CD, I'll say MCD is equal to, right, I can use y2 minus y1 over x2 minus x1. Okay, please mark your way. Right? My y2, I'm going to consider this 0 as my y2 and that 6 is my y1. Or I can do it vice versa. Okay, let me say 6 minus 0. So this is my y2, that's my y1. Okay? All over 7 minus 3. So I'll get 6 over 4, which is the same as 3 over 2. Okay? There is no need for you to convert it to a decimal. There is no need. Okay? It's the same thing, but there is no need. Okay? There is no need for you to convert that to 1,5. Okay? If you want, you can convert it to a mixed number, but it's not important. Because 3 over 2 is the same as 1,5, the same as 1.5. So if you get 3 over 2 like that, read it like that. Okay, then the next question says calculate the size of alpha. Now the reason why I gave you this question was because of 4.2 and 4.4. Okay, angle of inclination. Angle of inclination. Can you put your phone down? Alright, let's carry on. You can see the diagram. So you want to find the size of that angle. Now alpha, for this diagram here, it's an angle of inclination based on the definition I gave you. The line CD is slanting to the right, therefore the gradient is positive. Okay? So for that question, we can use tan alpha equal to m, because we just want to get alpha. Let me do it here, just to save some space. So to get that, we say tan alpha equal to m. Okay? Remember, the general formula that I gave you was tan theta equal to m. Okay? That was based on the angle that I gave you as theta. For this question, that theta that I gave you is in your notebook has been replaced by another Greek letter, alpha. So I replaced the theta by alpha. Okay? So that becomes tan alpha equal to, we found the gradient of CD, that's 3 over 2. So your alpha is going to be equal to shift tan of 3 over 2. Okay? And what would be the answer for the angle? 56,31 degrees. So that's your answer there. Remember, that's for question 4.2. Okay? That's for question 4. That's the answer for 4.2. Okay? Very simple. You should not get nervous when you see a question like that. Because Mr. Fonda gave the definition of what the angle of inclination is. Angle of inclination is an angle between the x-axis and a straight line. It is measured from the x-axis in an anti-clockwise direction. Okay? If the gradient is positive, your equation will be tan theta equal to m. In this question, alpha is equal to theta. So that's why I wrote tan alpha equal to m. Okay? Now let's move on to 4.3. Is there anybody else with a question so far? Right, 10.3. Sorry, that's 4.3. Now 4.3, I hope you all have your questions in front of you. It says, determine the value of y. Determine the value of y. Now, this one is a little bit tricky. It requires some thinking. You need to find the value of that y there. Yeah. That's where the y is there. Okay? Now, for you to be able to do question 4.3, it requires some thinking in the application. Right? In my case, this is how I would approach it. First, I found the gradient of that line, CD. I know that the shape of ABCD is a rectangle. So this angle is 90, that one is also 90. So AD is perpendicular to CD. So if I know the gradient of CD, I can find the gradient of AD. Okay? So I'm going to find the gradient of AD. Right? So I'll say, first thing, I know that the gradient of CD, MCD times M, okay, that would be MAD, will give me what? -1. Remember, if two lines are perpendicular, the product of their gradients is equal to -1. So the gradient of CD is 3/2 times the gradient of MAD, okay? MAD, that should give me -1. So MAD is going to be a -2/3. Okay? The gradient of MAD is equal to -2/3. I'm not done because I need to find the value of y. Now, for me to determine y, I'm going to use the formula for calculating gradient for line AD. So, I'm going to write the formula, calculate MAD. It's equal to y2 minus y1 over x2 minus x1. Where there is MAD, I'll put -2/3. Where there is y2, okay, I'm going to choose point D as my y2. So I'll have 6 minus y over 7 minus 4. Okay? And then you get -2/3 is equal to 6 minus y over 3. It becomes a grade 9 equation. Okay? It becomes a grade 9 equation. So I'm going to carry on the other side. So here I'll cross multiply. If I cross multiply there, I'll get -6 on the left. Okay? And then on the right, 3 times 6 will give me 18. Then 3 times minus y will give me -3y. So if I carry on there, I'll get -24 equal to -3y. Then you divide both sides by -3. So your y is going to be +8. Okay? Now, when you're answering questions on analytical geometry, it's very, very important for you to use common sense. Okay? I'm sure you can all see in the diagram that point A is in there. It's actually in the first quadrant. And in the first quadrant, y is positive. You must use common sense. In the first quadrant, y is positive. So you can't get a value of y here for this question, which is negative. Okay? Then for the question before I carry on. Yes? When you get a fraction on the left and another fraction on the right, if you have one fraction on the left and the second fraction on the right.
So if I drop 3, that means 1.
Amar, you can only cross multiply if you have one fraction on the left and the second fraction on the right. If you have got one fraction on the left and two fractions on the right, you can't cross multiply. You have to find the what? The LCD. Remember that. Okay? You remember find the LCD. Yes.
So I think what you meant was like drop the 3 since the same value.
All right, I see what you mean. Okay, in this case here, you can drop that 3 because that's a common denominator. Okay, so you can just drop the 3. Then you can end up having -2 equal to 6 minus 8 to give you the same answer. Okay, thank you for that clarification. Right. Are you all okay?
Yes.
Okay, let's move on. Now, 4.4, calculate the size of theta. Now, question 4.4, you have to apply all your knowledge now of inclination together with triangles and so on. Right, so let's go back to the question. Right, we're going to analyze the question for us to carry on with the question. Now we need to find theta. Theta, from the definition of angle of inclination, is theta an angle of inclination? Is this theta an angle of inclination?
No.
No, it's not. So you can't use tan theta equal to m straight away. You can't use theta equal to shift tan of m plus 180. You have to go via maybe triangles or any other method. Okay? Now, my suggestion here, or rather the way that I would approach it, I will use triangles. If you look at triangle ACD, we have this angle here. Okay? If we can find the size of this angle, okay, we know that ABCD is a rectangle. Therefore, AB is parallel to CD. Can you do me a favor and pay attention? Pay attention. Right. I want to make sure that if you have got issues later with this subject, you have no one to blame and say it was because of the situation. No, you have no one. You know that a bad situation can turn out to be a blessing in disguise. Like what I'm seeing now. I never used to use so much of technology like what I'm doing now. And it's becoming a blessing in disguise for me. Okay? Alright, so I need to carry on here. Make sure you pay attention. I'm saying theta is not an angle of inclination. So for me to get the theta, I'm going to use my knowledge of triangles. I'm going to calculate the size of this angle here. That is ACD. I can find it. Okay? For me to find it, I need the gradient. I need to find the gradient, or rather the angle of inclination of line AC. I need the angle of inclination of line what? AC. And once I find the size of this angle, I know what alpha is. I know what alpha is. So I can subtract alpha from that angle to get this angle. Okay? I can find the size of that angle, then I'll subtract the size of this angle from, I'll subtract alpha from the size of that angle. Okay, I'm going to give a name to this angle, I'll call it beta. Okay?
Really, I'm apologizing for interrupting. We've got the inspectorate here, so there's supposed to be social distancing of 1.5 meters between you. So can I ask you just to spread apart a little bit more? And as guys on that side, can you just go to the other table for me, please?
Okay, so, yes.
Can you just pick a point anywhere from that side and just make why did you pick that one?
Why did I pick this point?
No, the arrow.
Okay. You see, what the question, it's a higher order question. It requires some thinking. What is the objective? To get the angle of theta. But theta is not an angle of inclination. Okay? So how do I get there? I have to use my knowledge from previous grades. In this case, triangles. So I identified triangle ACD. I need to get the size of this angle. Okay? But for me to get it, I need to get the size of this bigger angle, which is a sum of this one and alpha. Do you see that? That if you add alpha and that angle, you get beta. Do you see that? Because if you can't see that, then you are going to have a challenge with the question. You won't be able to do it. Okay? I hope I've answered you. Right? The question requires thinking. I need to remind you all of that. The question requires you to what? Think. and apply your prior knowledge from previous grades. And when you're doing analytical geometry in grade 11, your knowledge of triangles is very, very important. Don't think that all everything you did in previous grades is not required. It's needed more than ever now. Because math is a continuous subject. Okay, so I'm going to find that beta.
What time does the test start tomorrow?
I told you, but I wrote everything on the book.
For 6.
Hey.
I wrote everything on the book.
So,
Okay, all right. So for me to get beta, I need to find the gradient of AC. Okay, so I'm going to find the gradient of AC first. Okay, I'm going to determine the gradient of AC. Like my package is dead, the battery needs to be charged. Okay, let me carry on. So my gradient of AC is going to be, this is 4.4. So it will be MAC will be equal to, now MAC is going to be equal to, in this case, I'll write 0 minus y, and y is equal to 8. So I can take 8 minus 0. So here I'll say 8 minus 0 over, this is 8 minus 0, then 4 minus 3. 4 minus 3, I'll get 8 over 1, which gives me 8. So the gradient of AC is what? Is 8. Which means I can say tan theta, please, I have said this angle is equal to beta. You are allowed to do that. Because this is analytical geometry. When you're in an examination, they'll give you a separate sheet with this diagram. So you can label that diagram based on what you want. Okay? No one should tell you that this angle must be beta. You can give it any other letter you want. Maybe you call it y and so on. As long as it's clear. So for me, it's what? Beta. Right? So when I write here, tan, it will be tan beta is going to be equal to m. Right? Which means my beta is going to be shift tan of 8. What do you get? What do you get? Quickly, please.
82,
Can you come again?
82,
82,87, like that. Yeah? Right. So that's the size of beta. Okay. I'm not done yet. Now I need to use that value of beta. Okay. So here, beta is got alpha plus angle ACD. So I'm going to write that down. I'll say ACD is equal to beta minus alpha. So that's that 82,87 degrees minus alpha. What's the value of alpha? What's the value of alpha? You've got it? Huh? So it's 56,31 degrees. What would be the size of ACD? Tell me quickly. 20 what? 26,56 degrees. Okay, please, this is not the final answer. Okay, but it is getting us to the final answer. Alright? So the size of angle ACD is equal to 26,56 degrees. Okay? Then the next thing now, I'm going to use my knowledge of geometry of straight lines together with the properties of a rectangle. Okay? The properties of a rectangle. Right? So, this angle is equal to 26,57. Right? Because the shape is a rectangle, AC is a transversal. Remember, when we taught geometry of straight lines in grade 8, this line is parallel to that, which means this angle is equal to what? To theta, because they are alternate angles. Okay? So, I'll write here, theta is equal to 26,56 degrees. Why? Alternate angles please, you don't write alternate angles equal. You write alternate angles, then you must state the lines that are parallel. It will be AB is parallel to CD. Okay?
Your physics next week.
So it will be AB is parallel to CD. Okay? You can write it therefore. Theta is equal to that. Okay? And then you are done. That's your final answer.
Is it a level 4 question?
Yeah, it's a high order question. Okay? Some learners in the test, they won't answer. Okay. Alright, do you have any questions?
Anything above 4 marks, I won't do.
Do you have any questions? I'm doing it both so that no one will give an excuse and say, I've never seen anything like this. Yes?
If we how many now then?
Okay. Alright, can I just ask the question, how do I know that the lines are parallel? Remember, I told you the first day that I introduced analytical geometry, first page. Do you remember there are 7 points that I told that you needed to refresh yourself? One of them was quadrilaterals. And the rectangle is the what? The quadrilateral. So you need to know the properties of quads. Okay? The opposite sides of a rectangle are parallel. You know that? Yeah. So I use that property of rectangle. This angle and that angle are alternate angles. Why are they alternate? Because AB is parallel to CD.
It makes it easy, right?
Why is AB parallel to CD? Because opposite sides of a rectangle are parallel. That's a property of rectangles. So AC is a transversal. It's a line which joins parallel lines. Therefore, this angle ACD is equal to angle BAC. In that case, BAC is equal to theta. Because they are alternate. I hope I've answered you. Any questions?
So the matter of how you label the parallel lines, you can either say like AB and BC, or BA and BC.
Okay, it's very important how you name it. You see, this angle, pay attention, is equal to that angle. Our transversal is that line. This is our transversal. Okay? That's the transversal. Okay? Which two lines are joined by that transversal, and those lines are such that they make two angles with the transversal. It's this line, which is what? CD and AB. You can't say this angle is equal to that, and then you say BC is parallel to AD. That's not correct. Because AD and BC, they don't take part in the formation of this angle and that angle.
No, so I get that. I'm just saying like, I know it's parallel and everything, you have to use that, but I'm saying if you say BA is parallel to CD, is that fine?
Yeah, it's fine. Okay. The naming, if you write AB, is the same as saying BA. If you write CD, is the same as saying DC. That's the same. Okay. All right. Thank you very much. Let's
Relax.
let's carry on.
Just to feel